The experience is going to be more than you ever anticipated, and it was that way for me to get onto the moon. Seeing this valley of Taurus Littrow, which is deeper than the Grand Canyon, as a matter of fact.
When Grok AI scanned thousands of images from the Apollo moon missions, no one expected anything unusual. These photos have been studied for decades by scientists and experts around the world. But this time was different. The AI wasn't just looking, it was analyzing patterns humans might miss. And what it found raised new questions that stunned even seasoned researchers.
First walked on the moon, some amazing new images are out. NASA's lunar orbiter snapped photos of the landing sites of several Apollo missions. Here they are. One shows astronaut footprints,
Sparking fresh debate about what we really saw on the moon. What if the truth about the moon has been sitting in plain sight this whole time? Join us in this video as we reveal the findings. When machines look where humans couldn't. For more than half a century, the images from the Apollo missions have sat in plain sight. Between 1969 and 1972, 12 astronauts walked across the moon during 6 successful landings, capturing thousands of photographs along the way. Armed with specially modified Hasselblad cameras, they documented the lunar surface in remarkable detail, even under the moon's harsh, unforgiving light. These images became one of the most studied visual records in human history. NASA eventually made the entire archive public. Scientists examined it. Researchers picked it apart. Even curious amateurs spent years combing through the images, searching for anything unusual. From time to time, people claimed they had spotted strange shapes or unexplained objects. But almost all of those claims were brushed aside. The explanation was usually simple. Pareidolia, the human habit of seeing patterns, faces, or structures where none actually exist. And to be fair, that explanation made sense. Humans are not perfect observers. We get tired, we lose focus. We start seeing what we expect to see. After hours of scanning similar-looking images, the brain begins to fill in gaps, sometimes creating meaning out of randomness. It's the same reason we see faces in clouds or figures in shadows. Our pattern recognition is powerful, but it can also mislead us. That's where artificial intelligence enters the story. Unlike humans, AI doesn't get tired. It doesn't bring expectations into the analysis. It doesn't get influenced by prior beliefs or popular theories. Instead, it approaches every image with the same level of attention, applying consistent rules from start to finish. More importantly, it can process thousands of images in ways no human ever could, comparing details across massive datasets, spotting patterns too subtle or too complex for the human eye. This is exactly what made Grok different. Developed by Grok AI, Grok represents a newer generation of AI systems built to handle large-scale analysis. When researchers decided to apply it to the complete Apollo photographic archive, the goal wasn't to prove a theory. In fact, they avoided that entirely. They gave the AI no hints, no leading questions, no specific targets. They simply fed it the entire dataset and asked one thing: find anything that doesn't belong. The approach was intentional. By removing human bias from the process, the researchers wanted results that couldn't easily be dismissed. Grok wasn't told what an anomaly should look like. It had to figure that out on its own, using established models of how the lunar surface is supposed to form and behave. What followed was weeks of deep analysis. Grok didn't just look at individual images in isolation, it compared them. It studied how shadows fell across the terrain, how light interacted with different surfaces, and how shapes appeared from multiple angles. It even reconstructed rough, three-dimensional models using overlapping photos taken from different positions. Every feature was measured, tested, and compared against known geological patterns. At first, the results seemed overwhelming. The AI flagged thousands of potential anomalies, but as researchers reviewed them, most turned out to have ordinary explanations. Strange shadow angles caused by uneven terrain, lens artifacts from the cameras. Small imperfections were introduced during film development, even digital compression errors from when the images were later scanned and stored. One by one, these were filtered out. What remained was something no one expected. After all the obvious explanations were removed, Grok was left with 847 distinct features that didn't fit. These weren't random shapes or vague impressions. They showed measurable properties, clear patterns, repeated structures, and geometric relationships that stood out against everything else in the dataset. The most striking discovery involved what the AI described as linear coherence patterns. Across images from all 6 Apollo missions, Apollo 11, 12, 14, 15, 16, and 17, Grok identified faint linear features that seemed to follow consistent orientations. These lines appeared in completely different locations, sometimes miles apart, yet maintained the same directional relationships. They weren't crater rays, they didn't match known fault lines, and they weren't obvious at first glance. Many were partially hidden under lunar dust or positioned near the edges of frames, easy to overlook during normal viewing. But when analyzed together, they formed a pattern, a very precise one. According to Grok's calculations, the probability of these alignments forming naturally was less than 1 in 10 million. The features were too consistent, too organized, and too widely distributed to be easily explained as a coincidence. At first, even the human researchers struggled to see it. The patterns were subtle. They required enhancement, side-by-side comparisons, and careful attention to detail. But once the relationships became clear, they couldn't be ignored. Lines that stayed parallel over long distances, angles that repeated with surprising consistency, arrangements that hinted at something structured rather than random. And that was only the beginning. The second major finding involved differences in how certain areas reflected light. Some regions in the images behaved differently under sunlight, showing reflectivity patterns that didn't match typical lunar soil. These weren't shiny metallic surfaces, nothing that obvious. Instead, the differences were subtle, slight variations in brightness and texture that suggested something unusual about the material itself. Even more interesting, these anomalies weren't scattered randomly. They appeared in clusters, often in areas astronauts never directly explored. And those clusters seemed to follow patterns of their own, aligning along certain directions while avoiding others. Then came the most controversial observation. Grok identified what it called structural shadows, shadows that appeared to be cast by objects with defined shapes. Not irregular rocks or natural formations, but forms with edges, angles, and proportions that looked deliberate. Straight lines, sharp corners, consistent dimensions, things that don't usually happen by accident in nature. To be clear, the AI didn't jump to conclusions. Every finding was assigned a probability score, reflecting uncertainty and the limitations of working with two-dimensional images of a three-dimensional surface. But even with those limitations in mind, dozens of these features were rated with high confidence as being inconsistent with known natural processes. And that's what made the results so unsettling. For decades, humans had looked at these images and seen nothing unusual, at least nothing that held up under scrutiny. But when a machine examined the same data without bias, without fatigue, and without expectation, it found patterns that had been hiding in plain sight all along. The question now wasn't whether something had been missed, it was how much. From machine findings to expert reactions, what did they think? Keep watching to find out. When experts took a closer look, when the researchers finally shared their findings, the reactions didn't come as a shock, at least not at first. Most experts responded the same way anyone would when faced with bold claims about the moon, with skepticism. That skepticism, however, didn't last long. As the team walked them through the process, how the AI had been trained, how the data was handled, and how the analysis avoided human bias, something shifted. Doubt slowly turned into curiosity. And curiosity, as more details emerged, turned into something far less comfortable: concern. One of the first to take a serious look was Dr. Marcus Webb, a retired planetary geologist who had worked directly on lunar samples during the Apollo era. He agreed to review the findings quietly, without his name being publicly attached. At the beginning, he wasn't impressed. Over the years, he had seen countless claims about strange objects or patterns on the moon. Every single one had eventually been explained: lighting tricks, camera flaws, or simple misinterpretations. He expected this case to be no different. But as he dug deeper into Grok's analysis, his confidence began to fade. The methods were solid, the statistical models checked out. The anomalies weren't vague or subjective. They were measurable, consistent, and difficult to dismiss. For the first time in a long while, Webb found himself facing something he couldn't easily explain, and he admitted it. "I've spent my career studying the moon," he reportedly said. "I thought I understood what was there. This data suggests I was looking at the same photographs everyone else was looking at, and somehow not seeing what was actually in them." He wasn't alone. Other experts who reviewed the findings reported a similar experience. They went in expecting to find flaws, but instead found themselves stuck. They couldn't point to errors in the process. They couldn't match the features to known geological behavior. Yet, at the same time, they struggled to accept what the data seemed to be implying. One reviewer, a specialist in image analysis, offered an interpretation that made the situation even more unsettling. According to them, the patterns Grok identified were exactly what you might expect if artificial structures did exist on the moon, but had been partially buried or worn down over time. Layers of dust, collected over thousands or even millions of years, could easily soften edges and hide clear outlines. In other words, the reason these features weren't obvious might be because they were never meant to be. That idea opened the door to questions no one seemed eager to answer. If something artificial really was there, who built it? When? And why had it never been officially acknowledged, despite decades of study? Rather than jump to conclusions, the researchers decided to take a different approach. They turned their attention to NASA's own records, hoping to understand whether similar anomalies had ever been noticed before. What they found didn't provide clear answers, but it raised new concerns. Since 2009, NASA's Lunar Reconnaissance Orbiter has been mapping the moon in extraordinary detail, capturing images far sharper than anything from the Apollo missions. Millions of these images have been released to the public, covering nearly the entire lunar surface. But when researchers compared those images to Grok's findings, something stood out. Certain regions, especially those where the AI had detected clusters of anomalies, seemed to have fewer high-resolution images available than nearby areas. It wasn't a complete absence, but the difference was noticeable. There are, of course, reasonable explanations. Orbital paths, mission goals, and technical limits all affect which areas get photographed more often. Still, the pattern was hard to ignore. Even more concerning was what they found in the original Apollo archive. Some of the photographs flagged by Grok appeared to be available only in lower resolution compared to others from the same missions. Given the consistency of the original Hasselblad film, this raised questions. Why were some images clearer than others? Again, there were possible explanations: film damage, processing differences, or issues during digitization, but the overlap was difficult to dismiss. Many of the images with the most significant anomalies were also the ones with the least detail available. To clarify, the researchers requested access to higher quality scans of specific photographs. The answer they received was unexpected. They were told that the original film was too fragile to be rescanned, and that the existing versions were the best that could be provided. Further improvements, they were informed, simply weren't possible. For the researchers, that explanation didn't sit well. They knew that NASA had successfully rescanned Apollo-era film multiple times over the years, using newer and more advanced technology each time. The idea that better scans couldn't be produced now seemed inconsistent with what the agency had already done before. And with that, the questions only grew deeper. Experts took a closer look, but what did silence reveal? Stay tuned to find out. Silence, patterns, and the places no one visited. As the investigation deepened, some researchers began to step back and question what they were really seeing, not just in the data, but in the response to it. What if this wasn't a hidden conspiracy at all? What if the silence surrounding these anomalies had a much simpler explanation? They considered the possibility of institutional reluctance. NASA, like any large organization, operates within certain boundaries. Its scientists rely on funding, reputation, and credibility. Publishing findings that can't be clearly explained comes with risks, especially when those findings could easily be misinterpreted or sensationalized. Drawing attention to unexplained features on the moon might invite more speculation than science. So, perhaps anything that didn't fit neatly into known models was quietly set aside. Not hidden, not erased, just avoided. In that light, the absence of discussion around unusual features might not point to a cover-up, but to something far more ordinary: caution. A culture that naturally favors clear answers over unresolved questions. A system where scientists, consciously or not, choose to focus on what can be explained and leave the rest alone. It was a reasonable theory. But then there were the patterns Grok had uncovered. Some of them were too large, too consistent, and too widespread to be easily ignored. The linear coherence patterns alone stretched across all 6 Apollo landing sites, forming relationships that spanned hundreds of kilometers. These weren't tiny details buried in a single image. They were structural patterns that, once recognized, seemed difficult to overlook. If NASA scientists had seen them, their silence would have required more than caution. It would have required a decision. To explore that possibility further, researchers narrowed their focus. Instead of looking at the entire dataset, they zoomed in on one specific location, one of the most well-documented sites in the Apollo archive: Apollo 15. In July 1971, astronauts David Scott and James Irwin landed in the Hadley Apennine region, an area known for its dramatic landscape. Over the course of 3 moonwalks, they spent more than 18 hours exploring the surface, covering more ground than any previous mission. The site offered something unique: a massive channel known as Hadley Reel, believed to have been carved by ancient lava flows. It was also one of the richest sources of high-resolution imagery, and according to Grok, one of the most unusual. Within photographs taken near the base of Hadley Reel, the AI identified a cluster of features that stood out sharply from the surrounding terrain. Researchers began referring to them as examples of architectural geometry. These weren't vague shapes or suggestive outlines. They showed clear structure, right angles, parallel lines, and proportional spacing. When measured and analyzed, the probability of such formations occurring naturally was calculated at less than 1 in 50 million. Even more intriguing was how they appeared. The features seemed partially buried, as if covered over time by layers of lunar dust. Their edges weren't sharp and exposed, but softened, consistent with something that had been sitting there for a very long time. And their placement wasn't random. They aligned with one another, forming relationships that suggested deliberate positioning. Some even appeared along the rim and inner walls of Hadley Reel, locations that, from a strategic point of view, would offer wide visibility across the surrounding landscape. When researchers enhanced the images using modern tools, the effect was striking. What once looked like uneven shadows began to resolve into defined shapes. Lines became clearer, angles more precise. Patterns that were easy to miss at first started repeating in ways that were hard to ignore. The more closely the images were examined, the less random they seemed, and yet the astronauts never went there. Despite traveling within a few hundred meters of these locations, their routes never brought them close enough for detailed inspection. From orbital views, their paths are clearly mapped, and they pass near the anomaly clusters, but never directly through them. Whether that was a coincidence or something else is impossible to say. But it wasn't the only detail that raised questions. Mission transcripts from Apollo 15 include moments where the astronauts briefly mentioned seeing unusual features. In several cases, those comments were followed by instructions from mission control to switch discussions to a different communication channel. What was said on those channels has never been made public, and Apollo 15 wasn't unique. Similar patterns appeared in data from later missions. Apollo 16, which explored the Descartes Highlands, produced images showing geometric features near North Ray crater, features Grok also flagged as highly unusual. Apollo 17, the final mission, returned with extensive photography from the Taurus-Littrow Valley, where multiple clusters of unexplained structures appeared in the analysis. Across different missions, different terrains, and different conditions, the same story seemed to repeat. The anomalies weren't scattered randomly. They appeared in clusters. They favored certain types of terrain, and they maintained geometric relationships that pointed towards something physical, not photographic. Even more curious was how these locations related to astronaut activity. According to Grok's analysis, areas with the highest concentrations of anomalies were consistently left unexplored. Astronauts traveled near them, but not into them. They focused on other objectives, collected samples elsewhere, and moved on. There are practical reasons for that. Time on the lunar surface was extremely limited, and every movement was carefully planned to maximize scientific return. Not every interesting location can be visited, but still, the pattern lingered. If unusual features had been noticed ahead of time, during mission planning or image review, would astronauts have been guided away from them? Who knows? Silence met new images, but what unexpected reaction followed? Let's find out. A new image and an unexpected reaction. As the discussion around Grok's findings continued to grow, something else happened, something far more recent and far more public. A photograph. During the Artemis II mission, astronauts captured a fresh view of Earth as they traveled toward the Moon. It was a historic moment in its own right, the first crewed lunar journey in over 50 years. Naturally, the crew documented what they saw, and one image in particular quickly spread across the internet. Taken by Reed Wiseman, the photograph showed Earth from deep space, framed through one of the Orion spacecraft's windows. In one version, only a curved portion of the planet was visible. In another, the full Earth appeared, blue oceans wrapped in thick, swirling clouds, with a faint green aurora glowing along the edge. It was, by all accounts, a beautiful image. NASA shared it publicly, celebrating both the mission's progress and the view itself. One official described it in simple but powerful terms. Aside from the small crew on board, every human being was captured within that single frame. But what caught people's attention wasn't just the image, it was the comparison. NASA paired the new photograph with a famous image taken during Apollo 17, one of the most iconic views of Earth ever captured. Side by side, the two images told a story of time, more than 5 decades apart, yet showing the same fragile planet floating in space. NASA's message was clear. Technology has advanced, missions have evolved, but Earth remains just as breathtaking. Online, however, the reaction took a different turn. People began to notice something subtle, but hard to ignore. The newer image didn't look as sharp, it appeared slightly hazier, less crisp than the 1972 photograph. The colors seemed softer. The details are less defined. And almost immediately, questions started pouring in. Some wondered if it was simply a matter of camera differences. After all, the Apollo missions used high-resolution film photography, while modern spacecraft rely on digital systems. Others weren't so sure. A different explanation began to spread: climate change. Commenters speculated that the haziness might reflect real changes in Earth's atmosphere, more pollution, more particles in the air, and more distortion of light. A few responses were measured, asking whether environmental shifts could affect how the planet appears from space. Others were more dramatic. Some claimed the planet looked duller than before. Others blamed global warming outright, suggesting that what people were seeing was visual evidence of environmental decline. A few comments even veered into exaggeration, turning concern into speculation. But beneath all of it was a simple observation. Something looked different. Whether the explanation was technical, environmental, or perceptual, the comparison sparked a wave of curiosity. People weren't just looking at the image, they were analyzing it, questioning it, and trying to understand what had changed over time. And in a way, it mirrored what was happening with the Apollo photographs. For decades, images had existed without raising major concerns. Then suddenly, with new tools or new perspectives, people began seeing details they hadn't noticed before. Patterns, differences, anomalies, things that had always been there but hadn't been fully examined. The Artemis II photo became another example of how perception can shift. Two images, same planet, different eras. And yet, when placed side by side, they didn't feel identical. Some saw it as proof of change. Others saw it as a reminder of how technology and interpretation can influence what we think we're seeing. Either way, it added a new layer to an already growing conversation. Whether it's the surface of the moon or the view of Earth from space, one thing remains constant. Sometimes, the more closely we look, the more questions we find. A new image sparked reactions, but what simpler explanation emerged? Keep watching to find out. A simpler explanation emerges. As the debate around the new Earth image continued to grow, not everyone was convinced that something dramatic had changed. In fact, many people began pushing back against the more alarming interpretations, offering explanations that were far more grounded and far more likely. The first point raised was surprisingly simple: lighting. Several observers noticed that the newer image didn't show Earth fully lit by the sun. Instead, it captured a portion of the planet that was turned slightly away from direct sunlight. That alone could explain the softer, dimmer appearance. One user broke it down clearly. According to them, what people were seeing was closer to the night side of Earth. To make that side visible at all, the image would need to be adjusted, brightened, or overexposed. And when that happens, fine details can start to look grainy or washed out. In other words, the image wasn't worse. It was just different. Another person echoed the same idea, pointing out that the older image from Apollo 17 was taken under ideal conditions. The planet was fully illuminated, with the sun positioned perfectly behind the camera. That kind of lighting naturally produces sharper contrast, deeper colors, and clearer detail. The newer photo, taken during Artemis II, didn't have that advantage. Here, the sun was positioned differently, partially behind Earth rather than shining directly onto it from the camera's perspective. That shift alone can completely change how the planet appears, even without any environmental factors involved. Then came another layer to the explanation: image processing. Some users pointed out that the famous 1972 image, often called the blue marble, has likely been adjusted over time. Color correction, contrast enhancement, and other visual tweaks can make an already good photo look even more striking. Meanwhile, modern images are often processed differently, especially when they're shared quickly on platforms like X. Compression, resizing, and automatic adjustments can subtly reduce clarity or alter how colors appear. So what people were comparing might not be a perfectly fair match. One image was taken on high-quality film, carefully developed and later enhanced for clarity. The other was captured digitally under different lighting conditions and optimized for fast online sharing. Naturally, they wouldn't look the same. To settle the debate, one user even turned to Grok for a more technical breakdown. The response added useful context. The Apollo-era photograph, Grok explained, was taken using 70mm Hasselblad film, which is known for its exceptional detail and dynamic range. Combined with near-perfect lighting, that setup produced the crisp, vibrant image people still admire today. On the other hand, the Artemis II photo was captured using modern digital sensors aboard the Orion spacecraft. While advanced in their own way, these systems operate under different constraints. Lighting angles, atmospheric interference, and even post-processing choices can all influence the final result. And when those factors don't align perfectly, the image can appear softer or less defined. But that doesn't make it inferior. It just means it was taken under different conditions, in a different era, with different tools. In the end, the simplest explanation turned out to be the most convincing. There was no clear evidence that the Earth itself had changed in the way some feared. What had changed was perspective, how the image was captured, how it was processed, and how people interpreted it. It was a reminder of something important. Sometimes, what looks like a mystery isn't a mystery at all. It's just a matter of understanding the details behind the image. Simple explanations appeared, but how did viral images mislead everyone? Let's find out. Viral images that weren't real. As excitement around Artemis II continued to build, so did the flood of images online. The mission had already made headlines for pushing human spaceflight farther than it had gone in over 50 years. Naturally, people were eager to see what the crew was capturing along the way. But not everything being shared was real. Within days of the mission's launch on April 1st, social media platforms, especially X and TikTok, were filled with stunning images claiming to show fresh views of the moon. Some posts displayed detailed landscapes with unusual angles. Others showed the lunar surface glowing with vibrant colors, far from the familiar gray most people expect. At first glance, they were impressive. One widely shared post described the images as stunning high-resolution moon photos, pointing out how surprisingly colorful the lunar surface appeared. Another user expressed amazement, claiming they had just discovered that moon rocks weren't simply dull gray. but full of hidden color. There was just one problem. None of those images came from Artemis II. Some went even further. One viral post featured what looked like a breathtaking scene from inside a spacecraft window. Earth rising above the moon's surface, captured from a perfect angle. The caption simply read, "What a sight!" It looked convincing, cinematic even, but it wasn't real. Fact-checkers at PolitiFact stepped in to investigate the growing wave of viral images. After reviewing the claims, they confirmed what many had started to suspect. The photos being shared were either taken from older missions, heavily edited, or completely fabricated. To be certain, they reached out directly to NASA. The response was clear. The agency directed them to its official releases, where authentic images from the mission were being published. None of the viral photos matched anything in those collections. They weren't part of the mission's official documentation, nor were they found anywhere on NASA's website. A NASA spokesperson emphasized this point, explaining that anyone looking for real Artemis II images should rely on official sources. If an image wasn't there, it shouldn't be trusted. Despite that, the misleading posts had already spread widely. Why? Because they tapped into something powerful: expectation. People wanted to see something new, something different, something that would change how we view the moon. And when images appeared that seemed to deliver exactly that, bright colors, dramatic angles, almost surreal beauty, it was easy to accept them without question. So, what do you think about the results from Grok AI? Let us know in the comments section below. In the end, it wasn't just about Apollo photos or Grok AI, it was about how we see the same images in a completely new way. Old data, new tools, and suddenly, nothing feels as certain as before. If you enjoyed this story, like, subscribe, and stay tuned for more real-life space mysteries.